Just waiting for last minute people to pop in. Then we'll be good to go. All right, so we could go ahead and get started. Well, we made it. So this is the last part of our quick Coding 101 series. And today we'll be doing a quick project. And it's going to be using both an input device and an output device. And our input is going to be a light thermin. Basically what this does is it sees light intensity and it gives a value. And then we'll be using audio feedback to see how much light we have. And we'll be using a buzzer for that. So going to the hardware we need, once again, we're going to need the Arduino because that will be our central base for everything. So we have that. I won't be getting back into the pins and everything on the Arduino since we already discussed that. And same thing, we're going to need a breadboard again. So the new items we're going to need are actually a photocell. So it should look like this brown piece. You could also see on the screen. So that is your photocell, and what it basically does is it sees more light and it translates it into electrons as a quantity. So more light means more electrons. The other main thing we're going to need is the buzzer. So that basically it acts kind of like a speaker. So depending on how much light you have, the more light you have, the louder your buzz is going to be. Right. So one thing that I guess I forgot to put in the slide is you will be needing a resistor, and that is going to be a 10 ohm resistor. So if you need help finding that, that's actually going to be your golden, orange, red banded resistor. So if you need help finding that, you're more than welcome to use the chart from last week. All right. So while you guys are getting those parts together, real quickly, so these are the Arduino functions from last week. We will be using some of them again, not all of them. However, there are some new functions that we need to know, and those are the int variable. So declares a new variable of type integer. Basically what that means is that it's going to change. So depending on how much light intensity we're getting in, the speaker volume needs to change. It can't stay the same. Analog read pin, and that's going to be returns a measurement of voltage on the pin of a value of 0 to 1023. Basically what that means is that we're going to be changing the power that goes into our buzzer, because if we go way too high, we're going to probably end up destroying our buzzer, and we don't want that. And if we go way too low, then we won't get any sound at all. Next one is going to be tone pin. frequency and duration. So this is actually 3 codes into one. So basically what this tells is how much, it kind of goes along with the analog read of how much we need our light intensity to stand for. And then finally the map value. So that's going to be converting from one range to another, other known as using a value of light intensity to sound intensity. All right. So next step is going to be one to set up our Arduino or configure it correctly before the software. So I'm going to unshare my screen for that real quick, just so hopefully you guys can see me a bit bigger. All right. So I have my Arduino, and if you need the schematic, it's actually available on my website as well. So basically for this job, the first thing we're going to do is connect our Arduino to the breadboard. And the way we're going to do that is we're going to use 2 of our longer wires. And then we're going to convert one wire needs to go into our breadboard, the other going into our Arduino. First what we're going to do is power and ground. So the negative let me get a different wire, that one's gone. Our negative is going to go into our ground. Once again, we have 2 grounds, so it doesn't really matter which one we go into. And then our power is our next one. So we will be going from our positive side. Once again, it could be anywhere on the positive row. And then we're going to plug that into our 5 volts. This project does require a bit more energy. That's why we're using the 5 volt instead of the 3 volt used last week. Basically, a rule of thumb would be if you're using just a LED, you could go with 3 volts. However, if you're using something more than just a LED, definitely go with 5 volts. Right. So now we have power going into Arduino. So that's one thing solved. Now that we have our external power, we do need to connect. We're going to set up our actual system of what's happening. So first thing we're going to do is connect our buzzer. So in order to connect our buzzer, okay, we can place it anywhere on our breadboard, as long as we know where our row and column is. So I'm actually going to place mine there. So I'm placing mine at 10 and 14. These numbers will be important because I can't see the bottom of the buzzer, so I will need to cut that off. And then we're going to connect from, we're going to be using the 8 port again. Once again, it doesn't really matter which port you use as long as your code matches. However, I'm familiar with 8, so I'm going to use 8. And then the first one we're going to plug into is our 10. Let me actually take my buzzer off so I could see. Connect into our 10. And I'll also connect into our 14 row as well while I'm at it. And then reinsert my buzzer. Okay. So that was quite a few steps. So let me show this to you guys real quick after I get this wire out the way. There we go. So So far I have my buzzer plugged in and my power cables and 2 wires, one going into the buzzer and one coming out of the buzzer. Now the buzzer okay, that was loose wires, okay. And there we go. All right. So now our buzzer actually, it does need power, or additional power. So we're going to be connecting the ground wire to it. I could use a smaller one. So to our 10 row, we're needing power. My buzzer obviously does not want to go in today. There we go. So now we have our power connected. It's kind of hard to see with the buzzer in the way, but our buzzer, power, and our wire coming in from the 8-pin in digital from Arduino is all connected in the same row. Right. Right. And now this other wire that we had, we're going to connect it into our 8th pin. So let's go. Okay, I'm going to need to get a new wire. So my wires are a bit more older, so I'm having to change out wires. There we go. And then our 8th pin. The buzzer again. Nice. All right. So we have our output device plugged in. Now we do need to connect our input device. So to connect our input, we're going to grab our light thermin. And once again, we can put it on any row as long as we keep our everything constant. So let's go ahead and put it at, just to keep it a little bit distance, 20 and 23 or 22. One thing I forgot to mention is that for the buzzer and light thermin, it does not matter which side is positive, which side is negative, compared to the LED. Okay, so I actually ended up putting my light thermin into 20 and 25 just because it didn't fit into the 22. So as long as I keep it constant, it should all work out. All right. And next, we're going to connect from our power source. I don't need a big one, I need a smaller one. Okay. So from our power source to our light thermin, once again, it doesn't matter which one we go to as long as we keep it constant. So I'm going to go to the one on the left. So going to 20. Hopefully, there we go. And anyone on the positive side. There we go. Okay. Right. Next, we do need our resistor. So there we go. Our resistor, we're going to plug it into our 25 to go to our light sensor, and then the other side we're going to connect into our negative. There we go. And finally, we need to connect our thermistor to the LED or the Arduino in order to basically connect it, get power, code it, essentially. So one side goes into the 25, and the other side, we're going to use our analog pins, so we'll go into a 0. And I need to grab a bigger wire. All right, so finally we have everything plugged in. I'm scared to lift it because I don't want to throw everything out. But you can see that one side is handling all the everything for the light thermin, while the other side is handling everything for the buzzer. The buzzer has its own one way of energy circulation, so positive to negative. Same thing with our light thermin. It has its own energy of going from positive to negative. So they're not connected in a series. In the event that we did have them connected to a series, we wouldn't really need any code, or we wouldn't be able to code it because it will all be using the same intensity going through. Now, our next step is actually going to be to launch Arduino. So let me okay. Sorry, I guess you guys couldn't see. But basically, I connected everything to my Arduino, and one side is all for the light thermin, while the other side is all for the buzzer. The buzzer has its own circulation of energy, while the light thermin has its own. If you want, you are more than welcome to review the on the website the diagram that shows how to connect everything. Right. So as long as you have your, I didn't use the diagram exactly, but as long as you use the same row and the same column to connect everything, you should be fine. All right. So I'm going to go ahead and share my screen again because now we're going to go back into the actual code. So I'm going to launch Arduino again. All right. Here we go. Okay, so there are some things that we need to do. Let me enlarge that. Okay. So there is some code that we need to put in before any lines of code, before we get into our void setup and our void loop. So we need to actually label anything and the new code. So we will be using int excuse me, sensor value, and then what that stands for is a variable to rate, low voltage. There we go. Right. So basically what that means is that for our light thermin, whenever we place our hand over it, we need the value of it to change, or so it's going to be sensitive, so sensory, to the amount of light it has. The next variable we're going to need is to set what is our lowest that we could go and our highest. So as discussed earlier, it is 0 to 1023. Now, so int enter low. So what is the lowest value we can go to? Now, our lowest value is 0. However, in coding, everything is kind of inverse. So when you're going to from one device to another. So instead of going to or writing 0 here, our lowest value will be 1023. Then our next value is going to be our high, so sensor high equals 0. So when we are changing to different values, such as or multiple words in the same line of code, we do want to capitalize things just so it's easier to read our code. However, it does not make a difference to us if we're just coding it. However, like if you send the code to someone else, it just makes it easier for them to read the line of code. Right. Finally, we need to say where our thermin is going to be located. So we're at, or what are our bounds for our light thermin? So those are constant, int, LED pin, and it is connected into 13. Both 13. Great. So LED 13 actually is located on our Arduino. There's no way to actually change the location of that. All right. So now we're going to go into our actual code. This week, I hope that I could just simply write the code and not the explanation like I did like this earlier. However, I will say the explanation out loud. I just won't write it directly if that's fine. So our first is going to be our pin mode, and that's going to be in our LED. So one thing I guess you guys might see is if you see the color change, it's starting to read your code. You don't have any you don't have an improper code. So LED. One thing I forgot here is LED pin. So I do need to leave everything. Right. And then semicolons again at the end of our code. So our next line of code will be our digital write. So digital 2 words write for our LED pin. And then what is our high value? So our high yes. Okay. So how long our value needs to last? we could do 4 seconds, or let's do 5 seconds, just to keep it constant. So that will be while milliseconds value and are less than 5,000. It's milliseconds. Close parentheses, close off that code. We don't need parentheses, we can put a semicolon at the end there. Right. So basically, that was a lot of code. So let's go over what it was. So basically, our pin mode, where our output is, so our buzzer, this is talking about a high intensity. So we're going to have 2 lines of this. So we're going to have a high intensity and we're going to have a low intensity. So this is our high intensity. And then this is a variable time, simply for the reason that our hand is not going to stay there for 5, but we do need to indicate a time of how long we need the buzz to last, essentially. Right. So I'm going to go to 2 lines down. So we're going to go sensor value equals analog read, right? And then our analog input, or light thermin, that was at, so you could simply see where your light thermin is connected. So it was connected to A0. All right. Now, same thing, we have to define it. So if our sensor value is higher, so greater than, our sensor high, finding there, then our sensor high is equal to our sensor value. All right. Spaces. Okay. Now we defined our sensor high, sensor low, and then we did greater than. So what happens if it's less than? So we kind of need to define that. So we need to define our low intensity as well. So in order to do that, you can actually use the same line of code. So I'm going to copy and paste it. And less than this time. So what happens if it's less than? So when it's our sensor low, our sensor value, so we need like our threshold again. Then we want the LED to turn off. So on our Arduino, our LED to turn off. So we'll see that once it's demonstrated. And then digital write. LED in. Defining everything that happens. So this is our high, this is our low, and this is defining our output. Right. So our loop code. There's not a lot of loop code in this one compared to the last project. However, the one that is, it basically exists to define our buzzer. So, or light thermal, because that's what our input is. That's where we need the most code. So, sensor value equal to analog read a 0, 0, let's parentheses. And then defining it, so actual or int initial pitch equal to our map value or sensor value or sensor low, sensor high, and then defining those values. Let's put them at 50 and 3500. And then now, finally, so we know our range of our pitches. So now we need to define what our tone is, or how long we're going to play our tone. So tone 8 dash pitch, 20. So basically what this means is we're going to play a pitch of 20 milliseconds on pin 8. So pin 8 is actually our buzzer. So using our Arduino, if you connect it to a different pin, such as 7, you would just change that 8 to a 7. However, mine is connected to 8, so I will leave it at 8. Okay. And then finally, delay. This is the optional code, but delay 10. And the reason we put that there is to basically tell how much we want to wait between our different readings from our light thermal. So that is basically all of our code that we need today. Let me just make sure. So we have our defining all of our variables, and then going into our code. So our output defining where it's going to be. Now this is our high, so our highest sound. What happens if we have low? We don't need that. And then defining our constants. All right. So next step, connecting our Arduino. So I have it connected to my computer. So now we're just going to plug in my Arduino, hopefully so I don't break it. All right. I hear a few clicks from the buzzer. Right, make sure everything's just tightly down. Okay, and then you're going to go to it is tools. So and then Arduino Uno, make sure it's selected. Port, we're using the old school USB. And then verify and compile our code first. Save it. Okay, so there was a detected, so high was not declared in the scope. So digital write pin high. What was that? And so pin high. Did define it as 0. Right. Give me a second to read through this error message. Okay, so we did define that, so I'm not sure what's going on. Okay, so it is only that line of code that's not understanding. Oh, could just be that it had that space, which it didn't like. And nope, that was not it. You can high, wait. Yeah, second to just make sure. That's right. So that's correct. That is correct. So the only difference I see between my code and the one I have on Hold Up is his is all uppercase, which I'm not sure should make a difference. You could see maybe that, but okay, so that actually does make a difference. Nope. Nope, not that. Oh. So that one's spelling, so maybe it does make a difference. Same thing here. It is probably saying it's to make spaces. Oh, INT pitch, so make sure that space exists between. And they're not reading, so it doesn't like sensor value, low, sensor high. Oh, okay. So because our limit is set to 5,000, it needs to be in increments of 1,000. So it doesn't like the 35. You need to make that a constant to 4,000. So that should fix it. No? Oh. Yeah. So as you can see, coding is very picky. And the only mistake there was that I capitalized S and it should have been lowercase. But one thing about you might like about Arduino is that it it doesn't say it's just wrong. It kind of helps guide you where something's wrong. So now, once we got that, let's go ahead and save it, save our code, and upload to our Arduino. And then uploading. And there we go. So that will get annoying. So once I place my finger on our light source, it gets really loud. Once I take it off, it gets slower. But yeah. Okay, I'm not sure if you guys could hear me over that, but once I place my hand over the buzzer, it gets super loud. Once I take it off, it gets quieter. So hopefully you guys were able to notice that through the microphone. So basically that is our code for this. So that kind of concludes what we have. Any questions? Okay. Kim, thank you. Yeah, I wish I could see the chat before. Yep. Right, so that basically concludes our Coding 101 series. If there's any questions, so sensory low would be the maximum value and sensory high would be the minimum value. Yes, so because we're going from a input to an output, we need to define them differently. So our light thermin will be defining our input, our buzzer is our output, so they do need to be inverses of each other. Will you be doing other webinars? Maybe. I am not sure yet. If there is actually one that you guys want me to do, I'm not sure if a survey goes out after this, but if there's not a survey, you could go on my website and just type in like a quick note to me on the homepage saying like you were in this webinar and you want to see maybe this next. I'll try to make it happen. Are you experienced in engineering by any chance? I am a little bit. I took engineering in I started taking it in 9th grade. Then I went to a middle college, so they didn't offer the engineering courses, so I couldn't take any there. And then when I went to college, then I did take a little bit of engineering courses, but then I went back into my major, which was biochem. Do you know any good applications for C++? Java is the best, I guess. Any of them, they're all different. They all have different uses. So it just depends on what you're trying to accomplish. For good applications, I'm not exactly sure if you were asking for which system is best to use to code it, or like how it could be used in the real world. C++ is used in anything such as, so like would C++ be more useful for creating games, web apps, mobile apps, etc. C++ is definitely more centered around digital coding. So yes, games, web apps, anything that would have like a image pop up or populate would be C++. All right, any more questions? All right, so I guess we'll be here for another 2 more minutes, and if there's no more questions, we'll go ahead and close off for today. So is HTML useful by itself, or is it better used with other codes as well? So HTML it can be integrated into other codes. So actually, my website is actually HTML, but then the forms and everything are a separate HTML code. So you could embed HTML into HTML. So I guess it depends on what you are trying to accomplish. So HTML doesn't have to stop with just websites. It could definitely go into forms, quizzes, a lot of academia. I don't know if your school uses Moodle or Canvas or Blackboard. That is all HTML. All right, guys. So I hope you guys enjoyed today's session and the series. So I guess I will see you guys in the future. Bye.